All right, let's dive in. Today, we're talking about the unsung hero of the modern business world, the data warehouse. It's this powerhouse that's secretly running behind the scenes, fueling every single smart decision a company makes. We're going to break down exactly what it is and why it's so incredibly important.
So let's start with a question that probably seems super obvious. You've got a company, right? It has a database with all its sales, all its customer info, everything. So why can't they just run their reports directly on that? I mean, the data's all there. Well, as it turns out, that very question is the whole reason data warehouses even exist.
Okay, to really get why, we need to get our heads around a really core idea in the data world. It's the huge difference between the systems that run the business day to day and the systems that analyze the business to make it better. Yep, we're talking about OLTP versus OLAP. So imagine this. Your operational database, that's OLTP, is just like a supermarket checkout. It's built for one thing and one thing only: speed. Get one customer through at a time, super, super fast. Scan, pay, boom, next. It saves data in rows, like a receipt for a single transaction. But a data warehouse, that's OLAP, is totally different. Think of it like a massive research library. It's not built for quick little transactions, no way. It's built for asking those huge, deep, complex questions. And here's the magic trick. It uses something called columnar storage. So instead of reading every single page of every book in the library, it can just scan one thing, like the author column, across the entire library at once. It's an absolute game changer for analytics. So let's put a clear definition on it. What is a data warehouse? Well, at its heart, it's a central hub. It literally pulls in data from all over the place, your sales system, your marketing tools, your inventory logs, you name it, and brings it all together. And this creates something incredibly valuable, what we call a single source of truth. It means everyone in the company, from the CEO down, is looking at the exact same data, the same numbers. No more arguments about whose spreadsheet is right. Okay, so we know what it is, but how does all that messy data actually get into the warehouse? Let's follow a little piece of data on its journey from being completely raw and chaotic to becoming a clean, super useful insight. For years, the process was called ETL: extract, transform, and then load. But things have changed. The modern way completely flips that on its head. Now it's ELT. We extract the raw data, load it straight into the warehouse, and only then do we transform it. Now, why the big switch? Well, it's pretty simple. Modern cloud warehouses are just so ridiculously powerful now, it's actually faster and way cheaper to just dump all the raw data in and let the warehouse itself do all the heavy lifting of cleaning and organizing it. All right, here's a super important tip. Or maybe think of it as a common mistake you absolutely want to avoid. Just loading the data isn't enough. You got to organize it. Forgetting to tell the warehouse how to physically sort or cluster your data, man, that's like taking all the books for a new library and just throwing them into one giant pile on the floor. Imagine trying to find one specific book. It's the same for your data. Defining these keys is like putting books on shelves by genre. It tells the warehouse exactly where to look, making your queries lightning fast, and trust me, keeping your cloud bill way, way down. And that actually leads us perfectly into the art of organizing that data library. We call it data modeling. This is all about how we structure the data to make it super easy to understand and quick to search. And the most popular way to do this, by far, revolves around two simple ideas: facts and dimensions. Let's start with the fact table. It's really as simple as it sounds. This table holds the numbers, the facts. It's the measurements, the metrics, the raw data that tells you what happened. How much did we sell? How many people clicked the link? How many units were shipped? It's all about the numbers. But here's the thing. Numbers by themselves are pretty useless, right? A sale of $50. What does that even mean? And that's where dimension tables come in. They provide all the juicy context. They're the who, what, where, when, and why. Who bought it? What did they buy? Where did they buy it? Dimensions are what give those boring numbers in the fact table their actual meaning. So when you put these fact and dimension tables together, you get what we call a schema. The most common one you'll hear about is the star schema, and it looks just like it sounds. You have your main fact table in the middle, and the dimension tables connect to it, branching out like the points of a star. It's simple, elegant, and super fast for running reports. Then you have the snowflake schema, which is a bit more complex. It takes those dimension tables and breaks them down even further, kind of like the intricate branches of a snowflake. It can save you some storage space, but it's a little more complicated to navigate. Okay, here's another pro-level concept that is absolutely essential to know. Think about this. What happens when a customer moves to a new city? If you just update their address in your database, poof, you've lost all the history of where they used to live. The standard way to handle this is something called a slowly changing dimension type 2, or SDD2 for short. Instead of just overwriting the old address, you create a whole new record for that customer. You keep the old one, but mark it as inactive. This way, you preserve history forever. It's a total must-know for accurate reporting over time.
All right, so what are the actual tools that make all this magic happen? Let's take a quick look at the big three cloud data warehouses that have totally changed the game. First up, you've got Amazon Redshift. It's kind of the OG in the space, and it's super tightly woven into the whole Amazon Web Services ecosystem. Then you have Snowflake, which is famous for one brilliant idea. It separates storage from compute. What does that mean? It means your finance team can run a monster report without slowing down anyone else in the company. It's genius. And finally, there's Google BigQuery. This one is completely serverless. You basically just throw your data at it and start asking questions. No managing servers, no fuss. It's amazing for absolutely massive data sets. Okay, all this theory is great, but let's bring it back down to earth. I want to walk you through a simple, real-world example so you can see exactly how all these pieces, facts, dimensions, all of it, work together to answer a real business question. So, picture an e-commerce company. The boss comes to you and asks, what were our total sales for product X, specifically to customers in California and only for last month? See how that question pulls from different places? You've got sales numbers, product info, customer location, and a date range. Trying to get that answer from your live day-to-day database would be an absolute nightmare. It would be slow and could even crash the system.
But in our beautiful data warehouse, it's easy. Here's how it works. First, the query hits the sales fact table to grab all the sales amounts. Next, it joins to the product dimension to filter for just product X. Then, it connects to the customer dimension to isolate only the customers in California. And finally, it links to the date dimension to narrow it down to last month. Because we set up that clean star schema, all these connections happen in a flash. It turns a super complex question into a simple answer in seconds. All right, we've covered a ton of ground here. Let's quickly recap the most important things to take away from all this. First off, remember that warehouses are for analysis, which keeps your day-to-day operations running smoothly and safely. Second, the new way of doing things is ELT, extract, load, and then transform, all thanks to the power of the cloud. Third, and this is a big one, good data modeling, like using a star schema, is absolutely critical. It's not a nice to have, it's the foundation of everything. And finally, remember that amazing tools like Snowflake, BigQuery, and Redshift have made all of this power more accessible than ever before. You know, to really drive this home, there's a quote I love that just nails it. The data warehouse is the brain of the modern enterprise. And as the engineer, you are the one making sure it stays sharp. I mean, how perfect is that? It really is the central nervous system for any smart company today. So I'll leave you with this final thought to chew on. With everything moving towards AI and real-time data, you have to wonder, is the data warehouse going to become a relic of the past? Or, and this is what I think, is it actually evolving? With things like the data lakehouse and AI-powered tools, is it about to become something even smarter, even more powerful than we can imagine? Something to think about. Thanks so much for joining me.